Test 1, 2, test. Good morning, ladies and gentlemen. So today we are going to start things off slightly different. So I've been talking with some of you on Reddit, which is fantastic. So thank you for engaging with me there. And it seems you guys have some concerns about what I am proposing to do here. So I thought we would start today with sort of a post-mortem on the Reddit post and a post-hoc Q&A, so to speak. So we'll start off here with a post from Ravnos. I don't know how to pronounce your guys' names, so I apologize for that. Good morning, Cheryl. And so what we are going to do is basically, excuse me. We're going to respond to some of these comments. So first one, Ravnos. And if you see your name pop up, feel free to jump into the chat on YouTube. I will be keeping an eye on that in case you want to respond to what I am saying afterward. But anyway, so Ravnos says, so what I am proposing would not result in a valid JSON, and it would need to be encoded in UTF-8 text, and that is mostly true. So first of all, I don't need it necessarily to result in a valid JSON. So as Lurgy1 mentions that a BSON document that you would use in, say, a MongoDB setting, it would not result in a valid JSON either. And that is, in fact, more what we're going for. So we don't need it to result in a valid JSON, but the part about the UTF-8 text is not quite right, because what we are talking about is just bytes. And all of these bytes they're encoded in some way that you will read back in some way. But if you read back those same bytes in the wrong way, you will still get an output, but it will just be nonsense output. And that's actually not really a problem. So even if you could take a file, so I have a file that we are going to be playing with today, and let's take this one, and I'm going to change it. This is just my usual profile picture. I'm going to change it to .txt, and I will use txt. So now the file is, when I open it to actually read it, it's encoded in a different way. So we're still going to have the exact same bytes, but it's going to try and read them in a different pattern. So when I open it up, it's just a bunch of nonsense. But that's okay. It can be a bunch of nonsense, because as soon as I have something that knows what to do with it, this was a .jpg, then I can change the name back. And this has nothing to do with the name. It's just that my macOS operating system knows that when it sees a .jpg, that it needs to open it with this program, which looks for encodings in this way. So if I open this again in preview, we see my profile picture. So it's the actual name of the file doesn't really matter, and the bytes are just bytes. It doesn't really matter where they are. So you're right. We're not going to get a valid JSON document out of what I'm proposing here, but we are going to be able to send files embedded within this document, because we are just going to be copying over the bytes. Okay, so let's look at the next comment. So this is from MoFH. I don't know how to pronounce it, but they say that they don't think my strict JSON is going to be that easy to parse. And actually, before we move on from Ravnos' comment, let me actually show you a little bit of code. So here we have an example, and I'm actually going to pull that image back to my desktop. Usually the icon changes back when I change the thing, but that's okay. Anyway, so what's going to happen here? So in this little sketch, by the way, the source code for this is on GitHub. There should be a link in the description. It will bring you to just my profile page. And from there, this is in the sketchbook. And we are on branch C file IO, so file in and out. So that's what we are looking at there. So if you want to see the code I'm working on, check out that link in the description and switch to that branch. So we are looking at this. So what I'm doing here is first I just open the file, that is my image file, and I quickly get the size of the file. This is a quick function that I wrote in my library over here that will just quickly get the file size and return it to me. So that's the number of bytes in the file in total. So I open this file and I get its size. Now I create a header, and this is what would be our JSON. This is the thing that is being accused over here by Mr. Oh, okay. No. We're talking about something else here. But this is, in fact, what MoFH is accusing of being difficult to parse. We're going to get there in a second, but I am currently showing you embedding this thing. I'm actually going to do it for you. So this is our header. This is what would be the JSON part of this. And what we're going to do is just stick this header onto the front of this file. So I create a void pointer called image that has the size allocated to it, that is the size of our file plus the length of our header, which is going to be 1, 2, 3, 4, 5, 6 bytes. So we're going to add 6 bytes to this. And then we are just going to copy over the header into our image void pointer. And then I'm going to, in the remaining space, read the file in. Then I can close that original file, and now I can open a new file. This is going to be our copy.jpg, and then I can just write that in. And actually, let's change it from .jpg to .block. We'll just call it something arbitrary, basically. So I'm going to run this, and what we'll see on my desktop is I now have this copy.block file. And if I open it with, I can't open it with text edit. Okay, so we're going to change the extension. Remember that that does not make a difference. We'll change it to .txt. And now I'll open it. And we can see that I have that same nonsense that I showed you when I just turned this into a .txt file. But we have this data prepended to it. And then we have all that nonsense. So this is basically how we're going to achieve our goal. Once I know what this is, then I can just remove it from the beginning. So this block of code that was commented out, let me close these really quickly and remove that. Once I run this, this is going to, again, open our copy, and we're going to call it .block. And yeah. Okay, so we'll open our copy, but now we're going to open it in read mode instead of write mode. And then we are going to also open a new file, a second copy, and we'll call it .jpg. We'll open this in write mode. And the size of this is going to be the size of our first file. Now, our second copy is going to be basically where we read in file B. So we are going to allocate the size that we need for that, and then we are going to read file B into that void pointer. But then we are going to create a second void pointer, and this one is going to be our final image. This needs to basically be this original file A size. So we're basically just going to subtract 6 from it because we know our header has 6 bytes to it. So we subtract 6 to create our final image, and then we do a mem copy on our second copy void pointer and our size here. Now, one thing I do here that's interesting to point out is this second copy plus 6. So second copy is a pointer and a void pointer. So how can you add something to a void pointer? Well, you're not adding anything in the sense that you would usually think of. Basically, you're just incrementing that memory address by 1 byte. So if we have memory address 100, then I would go to memory address 101. And so by incrementing it by 6, I'm basically just pushing that pointer 6 bytes over so as to skip over this part of the string. So when I run this, we can see that I have my original image, which still hasn't gotten its icon back. We have our copy.block, and then we have the image extracted from the block file. So that's basically how we're going to do this. We can know how long this is, or we can have some sort of delimiter to slice that, and we can just pull out that binary data and open it in whatever format we want. Now, that leads us into Moff's point. So anything we would want to use as a delimiter, basically, is going to, one of the children in my neighborhood is dancing outside my window. It's amusing. Anyway, so any delimiter that we choose to use is going to cause a problem. And let me demonstrate this in a better sketch. So let's add, I think I just have all there. This has some long branch names, so I'm going to just copy and paste it. Okay. So this is my proposal for an example. Oh, okay, well, it's not opening like that. Okay, here's a proposal for what I'm actually thinking that we would do. You would have, now, first of all, this is a formatted document. So I have all these tabs in here and these new lines. That would not actually be in the actual file. It would look more like this, which has all of the formatting stripped out of it. But for the purposes of looking at it, let's actually look at the pretty version. So you would have basically your headers here and then your data here. And we could have, as for example, well, let me just finish explaining it first. You could have whatever headers you want here. And then once you get to this data section, you know that after data : you have all of the binary data. And it doesn't necessarily have to be binary data. They could continue along with this embedded JSON format. They could do JSON format. They could do binary data. They could put whatever they want there. And they could encrypt it. It doesn't matter to us. We are just concerned with being able to pass this between nodes on our network and have everybody understand what's happening. So anything that comes after this data is what the client is putting in, and we put the responsibility of decoding that onto the client. So the point that Mof, it's an odd name. Anyway, the point that Mof is making is that it's going to be hard to find this point, because if we have this as our delimiter and we give them the option to input some text, then they could input this as their text, and we'll try to look at the rest of this as data, and the whole thing will get rejected. And one of the things about a peer-to-peer network that's kind of interesting is that you can kind of accept things getting rejected. So if you put in some safeguards so that if the head is far shorter than it needs to be, that means that they have put the delimiter into this field, and I'm just going to reject that. And this node on the network is free to create whatever documents they want, and they are welcome to try and send them to me, and I am welcome to not accept them. So on a peer-to-peer network like this, there is an element of strength in that someone who creates something that breaks the system isn't necessarily going to make it very far in the system. Anyway, so it's still going to be a problem. Even if it's a problem that doesn't have a big impact, it's a problem that we need to solve. So how are we going to actually delimit this? We could, for instance, put in as the first argument the size, or even better, header size. And then we would have like 5. That's how many bytes the header is. And then we would know that if you move 12,345 bytes in to this file, you would be right there. And that will tell us where the user's data starts. And we would also have this character. So their data would basically encompass everything between that and this. So we would need to also know that this last character is not part of it. A is, well, let's leave it there for now. Let's move on to a few other comments. So we could put the size of it as the first field, and then we could use that to find our starting point. But yeah, we'll put that aside for now. Anyway, let's look. I'm putting it aside because I know some people have asked questions that will bring it back up in a moment. Anyway. Okay, looking at file formats such as TIFF and GIF. So there are a number of comments here that I'm going to glaze over. Flat buffers being another one. People are offering third-party solutions, and I am not entirely opposed to using third-party solutions. And actually, in some of my planning for next week, I am using a third-party solution. But I generally am trying to avoid it. So I put out a poll last week on should I use third-party libraries, and I'll show you the results here. Well, not sort, but show numbers. So by a slim majority, most people are leaning towards no, and other people are ravenously in favor of third-party libraries. And I am largely against it myself. I'm kind of more on the only when absolutely necessary. And the reason is twofold. First of all, I want to know how things work. The whole reason I'm using C in the first place is that I didn't like how much Python was doing for me, and I did not like how much C++ was doing for me. And so I wanted to understand what was actually going on when I was programming. So that's why I came to C. And so to import some third-party library to just do a bunch of things for me is sort of defeating the purpose. Plus, I actually just want to know how this works. And so it takes more time for me to implement my own solution, but at least I know how to do it now. So if I wanted to actually use JSON, I could put the time into parsing that JSON string, and we could use actual JSON. I just don't want to. and I could also use a third-party library to just get that functionality right out of the gate, but I'm going to have to spend a bunch of time to learn how to use that library, and I could just use that time to make it myself. So I'm largely against using third-party libraries unless the effort to program it is so great and the functionality it delivers is so small that but necessary, because those exist. So in those circumstances, I'm willing to do it, and you'll see that next week. I'm working with OpenSSL and doing some cryptography things, and actually after having played around with it for a bit, I'm glad I did it because I can do some prototyping very quickly. That's a good reason to use third-party libraries. And actually, I went back to Python for that reason. Anyway, so you'll see in the next week that I think we can actually program those things ourselves. Anyway, so that's my stance on third-party libraries. Against it for the most part, but feel free to send me whichever ones you think are interesting. I'll take a look at them. Okay, this one is great. So, Lurchy1. It's an unfortunate name, Lurchy. All right, Lurch. So what you describe as your goal, metadata plus binary data, sounds more like HTTP than JSON to me in terms of structure. HTTP is also much simpler to parse than JSON. Okay? For example, since JSON describes a recursive data structure, your parser has to be recursive too. Indeed, it does. Consider the following example. Remember that JSON supports arbitrary nested arrays and objects. So yes, a dictionary inside of a dictionary. More special cases that you would need to consider for some characters, etc., etc. Okay, so yeah, so good, great point. So first point, ooh, something happened on the page. We're getting a slow bit rate, so let me know in the chat if that is looking weird to you guys. Anyway, let's continue on here. So Lurchy, good question, Lurch. So let's start with the recursive part. It absolutely would have to be recursive if we are putting dictionaries inside of dictionaries, but we do not fear the recursive function, Lurch. We do not fear it. So that's fine. We can do a recursive data structure or recursive loop function, whatever we want to call it. All of those. So we can do a recursive structure. That's fine. And I suppose it becomes... No, I guess so. You really just need to check what that first character is, because if it's a square bracket, then you're opening an array, and you would store that in a linked list instead of storing it in a dictionary. So yeah, but basically, it's not too hard. And then it being harder to parse, I largely disagree with that. So let's look at an example of HTTP. I was pulling up one. In my lessons somewhere. There we go, tutorials point. Okay, so let's look at an example. Here's a good example. Okay, so on this first line, you have 3 fields separated by spaces. You have post, this is your request type. You have the URI, and then you have the HTTP version. Everybody always uses the same HTTP version, but okay. The user agent, this is, in theory, well, let me just first say that this next chunk of some arbitrary unknown size is key value pairs. Okay, so we have space delimited variables on the first line. We have key value pairs in some unknown quantity as the second section, and then we separate by a space, and that's where we put our binary data, or whatever we want to put there. And Cheryl says that it's looking okay to her, so thank you for letting me know. Anyway, so then we have a space separating a section, and it's just an odd, inconsistent way of formatting data, and it's the inconsistency that really bothers me. But they are doing something that I am essentially copying here. So they have this section at the end for binary data. And that is exactly how I was proposing. I think the file is gone now, but if I open that with text, you'll see that it has prepended to it that data for a JSON file. And that's exactly what they're doing here. They delimit it with a double space, but I would delimit it with that data. And the only difference really is that I have another curly bracket on the end. So I would need to take that into consideration. So I do not think that HTTP is easier to parse than JSON. I find HTTP to be rather unpleasant to parse. If this was Python, sure, either one is fine. There's a library already there for it, but we're not using Python. We're using C, and so neither of these is going to be particularly easy to parse in C. But okay, the part of this that I really like, the part of Lurch's comment that is great, is this. The part about it being more like metadata plus binary is a perfect description of what we're doing here. So it is exactly that. If we look at this, what this is on our peer-to-peer network, this is a way of establishing what exactly this thing is that I am sending. So think about how this is going to work. We're going to have one node over here, and we're going to have one node over here, and then we're going to have 1,000 nodes in between. And this node is the one that created this file, and this node wants it. And so it's going to request it by going through all of the nodes. And let's just say that this node knows the existence of this file, but it does not know the existence of that node. So it is just going to send out a beacon message across the network asking for this file. And so all of these different networks are going to connect and search for this file until they get to this node. This node is going to present it to them. And this is a way of searching. So rather than thinking of the peer-to-peer network as like a website, think about it as a database. And the database is storing anything we want. Anything that you can store on a computer, you can store in the database. And we are coming up with a format that we can put around that data such that we can consistently pull it out and also identify it. So that is essentially what we are doing here. So this Lurch's comment is, I'm going to give him a little upvote for that. So thank you, Lurch. That is exactly what we are doing. So it's metadata and binary data. And it's the word metadata, that's especially great. It is we are essentially building the data about the data. Okay. Next one. Another third-party library. This is a third-party library, but this person worked on it, so I'm going to check that out because this guy worked on it. Anyway, Javier, welcome Javier. I recognize your name. So, I have been following your path in YouTube, and I have mixed feelings. Thank you for telling me that. There is some good things about the approach you take that, in fact, is triggering a lot of comments here. Doing stuff all by yourself, no external libraries. Furthermore, the idea of taking simple and well-known concepts and patterns. I just would think the goal should be marked for learning purposes and not as a viable solution for a more serious project. I agree fully with the comments regarding JSON. I would also admit that from the point of view of someone trying to grasp some programming concepts, it doesn't have to be the perfect solution. Even more, it's helpful to write it this way. And then learn by doing or suffering the corner cases that your approach presents. But it is relevant that you make the clarifications so that the audience is clear about it. And then Sir Cokes. Good. I second this comment. There are a whole bunch of problems and idioms being used throughout the code, and I can't recommend anyone taking these approaches to heart as a beginner/intermediate C developer. Yeah, okay. So, great feedback. Thank you for telling me that. It's most of you guys are very, very kind to me, and I worry that you are afraid to tell me when you don't like things. So I'm very glad that Javier and Sir Cokes felt like they could tell me this. And I largely agree with it completely. So I am not making, let's start by talking about the library. Let's start by talking about libyom. Okay, I am making this to use it. Okay, so for me, this is a production library. For you, I'm not making this so that you can use it necessarily. You can. If you follow along with this video series and you have as much knowledge about this thing as I do, then use it. Why not? But I'm more making it so that you can copy it. And what I'm thinking here is basically that everyone should know how a linked list works, and they should know it rather intimately. And the best way to do that is to make your own. And so that's what I've done here, is I've made my own. And I have shown you how I made my own, showed you how I've thought about it. And now, really, I am recommending that you go and make your own linked list. Here are some things that you can do when you make your linked list. And you're welcome to copy mine. You're welcome to copy and paste the code. You are welcome to put this in a production setting. If there is a section of the library that is exactly how you would use it, copy it. It's fine. But largely, I recommend that you make your own version of these things. Okay, this library is my toolbox, and you need your own toolbox. So that is sort of the thinking behind that. And now let's talk about the peer-to-peer network. So the way everything here is working is that, we've got Rogue is commenting. I'll come back to my thought in just a second. Sorry if this has already been asked, but any reason why your protocol needs to be plain text? Surely a binary format would be simpler to implement. I will come back to that in a moment. Rogue or rope? Rogue. Okay, I'll come back to that in just a moment. What was I shouldn't have even gotten distracted. Okay, yes. So here's how things are working around here. I have this library. This is my toolbox. And as I make things, I add things to the toolbox, and I use the toolbox. But I am making something else. So right now, I'm making a peer-to-peer network. And as I go, I put things in my toolbox, and I take things from my toolbox. But this project is separate from the library. It's its own thing. And Javier, I'm taking your comment in two ways. One is on the library, in which case I agree that it is, you should make your own linked list. And mine is an example that you can look at, but it's not one that you should just take on faith. Let me give you, let's take it yet another aside on that. So if you use the programming language Java, then they've already made it for you. And it implements a bunch of, and this isn't the source code for it, unfortunately, but it implements a bunch of it extends abstract sequential list and implements list, DQ, clonable, and serializable. And they've just gone ahead and made it all for you. So you're learning the programming language Java. A lot of what you're doing is learning somebody else's library. So you're just learning all of their idioms and all of their all of their weird things. What did this person say specifically? Problems and idioms. Yeah, that's Java. Problems and idioms. And oh my. Anyway, so since they've already implemented it for you, you're importing all of their problems and idioms, and you're doing the same thing with my library. And the whole reason I'm making my library is that I don't want to import someone else's problems and idioms. I'd rather make my own. And so I recommend you do the same. The project, though, the peer-to-peer network, that is not a library. This I'm actually wanting to use. And the entertainment for me in making this stuff is in having some sort of plan about how I'm actually going to use it. And so I am actually trying to implement a real solution here. How far that actually goes, I don't know. Doesn't really matter. It's just the fun of actually trying to do it. So I try and format these videos in such a way that they are educational, but in order for me to enjoy making them, I need to have some fun making things. And so that's really the idea behind the project. And yeah, I think it is, these videos are structured in a way that I am teaching things, but I'm teaching about what I'm actually trying to do. And I think that makes it more engaging. Anyway, okay, so Rogue's comment. Let me read it again so we can refresh our memories. Sorry if this has already been asked, but any reason why your protocol needs to be plain text? Surely a binary format would be simpler to implement. So it does not really need to be plain text. We could do raw bytes, and we could make, for example, a struct. So what am I in? Okay, so let's pull up main.c. We're already there, and let's give that a try. So if we define a struct, and we are going to call this, we'll call it JSON. Then we can put in some fields here, and we can call these fields, so we can put, what did I have? We can just put int size void pointer data. And then what happens when we create one of these JSON objects? This is our memory. We can say that each star is a memory address. This is our memory. what would happen if we created an int? It would take, let's say, these 4 bytes in an int, so it would take these. And then in our void pointer, let's say we give it 5 bytes. So now it's going to go 1, 2, 3, 4, 5. So that is going to essentially create a 9-byte array that is separated at a 4-byte marker between its integer and a void pointer data set. Yeah. There's a problem here. It's a problem that's a bit deep in there, so we're going to come back to it in a second. I'm just going to keep going. Okay, now the point here is that this is basically, since this is in a struct alt as 1, we can extract all of this together and just put this all as binary data. So if these last 5 locations are the actual file and these are size or whatever, that's our integer, then we can just take all of that as binary and write it out to a file and then load it back in C. Okay. There's a bit of a problem here. First of all, this. When we put a void pointer in here, what these memory addresses would actually be storing is a memory address, not the actual file. So if we save our file to this memory address, we would actually need to dereference it when we have it here. So one option is to have a what would we have? Character array. We could do a character array, but we won't know what size to make it. So again, actually, this is the same problem because an array is just a pointer. So those brackets are the same thing as doing this. So again, here we would have just a memory address. So that would have been the easiest possible way to turn this into like just a binary data file. But there are some problems with that as well. And also making it human readable is I think there are ways that can be an advantage. Okay, so I don't know. There's something like a MongoDB. Well, I guess their BSONs are. They are, in fact, binary. So they're not human readable either. So I'm gonna think about that actually. We might actually do that. That's a good idea. That's actually a really good idea. So I'm going to have to think about that some more, and I will experiment with that over the next week. So. If you have not joined our Discord, I would love to talk to you more about what you would do there for that. Anyway, okay. Any more comments that we want to address? Third-party library. Explanation. Okay. Big Pete. Big Pete. I think you're confusing a lot of people by referencing JSON when describing your data format. Format is quite simply not JSON. It isn't. Someone cannot put it into standard JSON parser and expect it to be decoded successfully. This would be clear if you gave your data format a unique name and at most reference JSON when describing its design. But I don't think it's necessary because anyone familiar with JSON will recognize it, and it's not important for understanding the design of your data format. Better to simply describe it as a unique format with no references to what it's similar to. I think that is fair enough. So I'm calling this embedded JSON. I guess that won't work. So ESON might work. They use BSON for MongoDB's binary JSON. So ESON. We'll use ESON. Okay. Plus is my name. So that's good for me. Anyway. Data format or for storage over network, I believe it basically works. Your intention is that you would always send the length of the binary data first in one of the fields and then the data right? Yes. Okay. In that case, the recipient knows how many bytes to read. Slightly wasteful but not harmful. Yeah, exactly. We were talking about that. Unless your intention is that the length might not be indicated, the recipient is supposed to know the data length by finding the closing thing. That'll work okay. Okay, let me address this, and then we're going to come to that last paragraph because he doesn't like it. I don't like you, Big Pete. No, I'm just kidding. You're fine. It's okay. So yes, it is a bit wasteful. Let's just go ahead and say that. So how are they going to find if we don't send the size? Let's look at our example here. Let's say we don't send the header size with this. We just send this file. Okay, so let's say we do parse it. I think that's he gives me the ability to parse it. The data length. He's talking about the data length. So we're going to assume that we have found the beginning of the data. Where am I? Yeah, we have found this point, and he's saying we need to know the data length. Well, the data length is just the rest of the file. So the rest of the file is the data length. And let's say that you have embedded another object in here, another JSON object, shall we say, and you put in something like this there, and we don't use quotes, so title, family vacation, and format, we'll call it JPG, and then we could say data again, and then you would have your file data in here. And this is arbitrary. You've just decided that this is what we want to have, and that's fine. This is your responsibility to decode this. What we need to know is that this is where things begin, and everything between here and the end of the file -1, again, that -1 is a bit wasteful, but everything from there on is your responsibility. So think about this. This is basically a database. So we are a database of nodes who are trying to share files with each other. So this is basically the header that is going to wrap our binary data files so that we can send them to each other and we all know what we're talking about. Now, I am going to assume that if you want this particular file, that you know what this is and that you know how to open it. So you should know that this is a JSON or an ESON with this format, and that you need to take this family vacation, make it the title. You need to take this and make it the extension of the file, and then this is the binary data that goes into it. That's your responsibility. Okay, so yeah, it's just the rest of the file, and as far as where the binary data is within that, it can be anywhere. It's your job to deal with that. There doesn't even have to be binary data in it. You can put plain text. Anything you want is fine. And that actually brings me back to Rogue's comment. So why not just send binary data? Why use plain text? Plain text is binary data. So maybe we're thinking too much about that. Anyway. Okay, leaving that aside, I don't love the format. Not JSON. It has some of the positive attributes that make JSON so attractive, such as being ambiguous and widely supported by existing libraries and applications. JSON is a data format, but what you have is both data and metadata. Repurposing JSON, or something similar to it, for this is doable, but perhaps not the best choice. I see little reason to prefer your format and protocol versus other ones such as HTTP style headers, content like the, okay. So the benefit of mine is that it's for a peer-to-peer network, not a client-server relationship. I don't know who has it, and they don't necessarily know that they have it either. We just know that it's there. And so let's say you're looking for a movie file, okay? And you don't know who has it. Who has it doesn't know that they have it, and nobody on the network knows where it is or anything like that. All we know is what it's named. It has a unique name on the network. So I send out a message to 100 nodes that I know, and I ask them if they have this. And they all check, and they say that, no, I do not have it. So they all send a message to 100 nodes that they know and ask if they have it. And that just keeps repeating until someone finds it, and then it gets sent back to the original requester. And so we don't need, I'm running out of battery here, so the camera's going to have to go in a second. We don't need to know. Nobody in that chain needs to know what is in this data section except the person who is trying to read it. Okay, and we do assume that they know how to read it. So this is going to get a unique identifier, and the metadata contains the data as well. Yes, that is actually its benefit. And yeah, by putting the metadata and the data together, we can search for it on a network and present it very quickly. So it's going to be much easier to find. So that's basically why. And that seems to be all of our comments. I'm not seeing anything else in the chat. I'm going to do a quick refresh here, see if anything new came in while we were chatting there. Nope, doesn't look like it. Okay. So my battery is running low, so I'm going to have to lose the face cam. You'll have to make do without my beautiful face. So we're going to pull the plug on that. Plug in my max battery. And I'm going to take 5 here. I'm just going to grab a drink of water, and I will be right back, and we are going to jump into actually doing some code. Okay, we are back. So I've shown you our implementation here, basically how that works. And we are basically appending just a short amount of text to our file. And our example is this one. We would have to change the name of it. And then we can see we have it prepended to the file. So the decision we have to make now, and this is basically where I am currently, is how do we want to format this precisely? So I've been showing you this example, and let's delete that so it's that, but let's delete this so that it's back up where it was. What's different? There we go. Okay, so that's back to where it was. Here's an alternative that I designed. So we have to ask if we want this to actually be compliant with JSON. I'm going to make this a bit bigger for you guys. So we have to decide whether we want this to actually be compliant with JSON. And I need to actually spill the beans a little bit on what this is actually going to be. So I'm thinking that in the end, or let's hold on. Let me switch my repository. Big reveal is coming. Okay. What we're actually trying to do here is use some hashes with it. So we have that data file. So let's imagine that this is our data file. What we would do is we need a unique ID for this data file. So what we're going to do is hash it, and that the resulting hash is going to be its ID. Do this in my terminal. Well, it's not here, unfortunately. I have to do the path. So we're going to do SHA-SUM A 512, and where is this? What is this called? Copy.txt. So that is a SHA-512 hash of the file. And that is how we're going to identify it in the database. You get this 512-bit hexadecimal number, and that is its ID. And so that's how we're going to be identifying them. And so I've been playing around with making these hashes, and let's hop back over to that other branch. Hold on. Okay, by the way, Apple, I've got 6 viewers here, so the odds of, 7, look at that. The odds of one of you working at Apple are pretty high. So if with Xcode, please make it so that the .gitignore already has this file in it, because it changes every time you look at Xcode. Anyway, so okay, so let's go back to file no, embedded JSON. Okay. So we have to decide how we want this. So we're going to be using a lot of hashes, and we're also going to we basically need to decide what goes in this, and do we decide if anything is mandatory in here. So in this data section, do we require that they put the size right there, and is the only option content, and then can they put whatever they want, or how much of this do we want them to be able to manipulate? And we are free to be strict here. We can say that, like, the initial header, everything up to this has to follow a extremely precise format. And then we can say that, okay, well, this is a slightly less precise format, and everything in this one particular content field is not precise at all. Or we could say that nothing here is precise, and that's basically the decision that we need to make here. And I don't have any ideas off the top of my head of what is going to be the best option. So I think what we are going to want to do is keep building out this whole way of storing data over here in the sketches, and let's not add anything regarding this to the library just yet. But there are actually a few things I want. No. We're good. We're good on that. Okay. So we're going to switch gears a little bit, and we are going to start hashing. And I'm going to talk about where this project is eventually going to go. And what we're going to try and make is a blockchain with this peer-to-peer network. So we are going to be creating hashes for everything, and it's going to work in a particular way. So if I swap over to this branch, you see, it's that file again. Okay. Good. Okay, so this file at the moment, here's what we are doing. This uses the OpenSSL library, and we're using EVP to generate SHA-512 hashes. And this is the thing, this is one of those instances where I decided I would go ahead and use a third-party library, and it's fine. I don't quite understand what is going on with this library, so it's a bit unfortunate, but we'll make do with it for now. I actually do think we can make what we need from this, but let's talk about what's actually happening here before we do anything else. So I'm opening this output file, and don't worry about this. This is just for measuring the results and storing the results. And basically what we are going to do is create bytes, a difficulty, a nonce, and a time. So we are going to go into this loop, and we are going to, well, in this instance of it, I have it going pretty high. We are going to go to, I think this is a terabyte. Yeah, I is representing our bytes. Is it? Or maybe it's just the iteration. I think it's just the iteration. Anyway, so we do this a lot of times just to get as big of a data set as we possibly can. And then we are going to create a random number between 1 and a gigabyte. So any amount of bytes between those numbers. And then we are going to create this block struct. Oops, need to do that, which just has a nonce and a timestamp in it. The nonce starts off as 0, and the timestamp starts off as the number of milliseconds, I think this clock returns. The number of clock ticks that have passed since the program began running. So that is its timestamp, and that's its nonce. And then we do this magic with with OpenSSL, and that's why I don't like using third-party libraries, because this is all just magic to me. Anyway, we create a SHA-512 MDCTX or digest. I'm not sure exactly what we're calling it. And we are going to hash that block. We are going to do that right here. No, we do that right here. So this is setting up some parameters. What we need is a difficulty for hashing this algorithm. Okay, so here's how it works. In a SHA-512, let's get that back. I had it here a second ago. There we go. So SHA-512 is a 512-bit hexadecimal number, and it's important to note that it is in fact a number. Take a look at this. This is a hexadecimal number, and it is too big for any data type in C. So if I put like a int x equals 0x that, we can see that this is a hexadecimal number, but it's way too big. And that's okay. We can ignore that for now. And what we want to do in our blockchain is essentially set a hashing difficulty. This is what allows you to mine. And what it basically means is that whatever number is generated by hashing the file has to be less than a certain number. And we measure this number by saying, well, the maximum possible number to store in SHA to the 250 or SHA-512 is 2 to the 512. What we do for our difficulty is 12 minus the difficulty. Okay? So here we are establishing the difficulty. And what we do is we create basically, we use the OpenSSL library to create a big num data type that holds 2 to the 512 minus our difficulty, which we calculate using this formula. Oh boy, this formula is interesting. We're going to come back to that in a moment. I want to give you an idea of how this whole program is working before we start jumping into this formula. Anyway, it's going to pick a random file size, and then we are just going to base our difficulty on that file size. So we can just kind of experiment with things. And we are going to, this whole difficulty is going to be this big num to the power of this big num. And we calculate that here. Or sorry, we calculate that here in R. And then we have one last big num that stores the hash, which we actually calculate by doing this. Is that the one? Where do we do that? Yeah, I think that's here. Is that here? Yes. So here we calculate the actual hash. Here we increment the nunts. We get the size. And yeah, we store that hexadecimal into this character array, and then we convert that into a big number. And we are going to repeat this loop. This loop is the one that calculates the hash, increments the nunts, and then saves the result. And we're going to repeat that so long as the hash that it generates is greater than our target difficulty. And so it's just going to repeat this again and again and again and again until it reaches that target difficulty. And once it reaches that target difficulty, we have hit the end, and we are going to print out the number of bytes that were hashed, the difficulty that was resulted from that number of bytes, the nunts, so basically the number of iterations in this loop, and the amount of time it took for that to happen. And it's also going to write all of that out to our output file. Now, one more thing to note about this is that this is kind of the most important part of the loop. So we calculate the hash for this. And odds are that hash is going to be too big. So when we come down here, we see that that hash that it generated is too big. So we're going to generate a new hash. But if we generate a new hash on the exact same object, you'll get exactly the same hash. I go here and I run that same command a bunch of times. The same input will give you the same output every time with these hashing algorithms. So something has to change in our block. Something has to change, and that's what the nunts is for. That's what's changing. So we increment it by 1 every single time, and we generate a new hash based on this new nunts. And that's how we are actually changing it. And over time, eventually, randomly, we will come up with a solution that fits the profile of our difficulty. Okay? So it makes a little bit more sense if you actually see it running. So let me actually change a few parameters here. So I want I to be less than 36, and our bytes are going to be 2 to the I power. Okay, so this is going to increase the number of bytes exponentially. And what you'll see is for very small bytes, you get very quick mining. And for very big files, you get slower mining. So let's run this. You can see it is updating. Let's hide a moment. So if we roll all the way back, we can see that first it was calculating 2 bytes. Difficulty was 5.4 something something, and it took 20 iterations in order to solve this hash. And then it started calculating for 4 bytes. It took 121 iterations to solve this hash. And then 8 bytes. And you can see that the difficulty is just increasing over time. Currently, it is hashing whatever the next one is in that. So it is at the last one it hashed. Well, there it goes. It's just solved it. So that number. So that number of bytes results in a difficulty of 24.536911. And it took my computer this many iterations to solve it, which was a total of 8.17 seconds. And now it's working on the next one in the chain. So this is basically what we are going for. Let's stop it and bring everything back. So these hashes are how we are going to basically be identifying things in our network. So we're going to have a bunch of nodes. Each node is going to have whatever blocks it has, or these embedded JSON documents, these ESON documents. And one of the nodes is going to reach out and ask for a certain block. It will ask by the hash that was generated. Let's see if I can pull that back up. How do I get the console back? Oh, it's not going to just let me see the console, is it? Of course not. Okay. Well, let's run it. Oh, I'm in the wrong one. That's why. Let's just run it again. Okay. So once I have done this mining thing, I end up with a hash as a result, and that's going to be the unique ID of an object on the blockchain or on our peer-to-peer network. So if I want a certain object, this is the ID I will use to reference it. And so if I want whatever data is stored here in these, however many, what is that, 262,144 bytes, if I want those bytes, then this is the ID by which I will reference it. I will send out a message to all of the nodes that I know that says, I want this block. And they're going to check if they have that block. And if they do, they'll send it to me. If they don't, they will ask everyone they know if they have that block. And it will just go out until someone finds it and sends it to me. And then I will do whatever I want with the data embedded in it. That's my responsibility. So over the next week, I'm going to be really trying to merge these two things together. And I'm going to need to make some decisions about how we are formatting different things. So how we are formatting those embedded documents needs to be decided on. And then I'm going to be working on merging these two things together. But there's something I wanted to show you. I'm forgetting off. What was it? I'm sorry. Very professional. At least there's only 3 of you right now. What was it? Oh, yes. The formula. The formula. Okay. This is a really interesting formula. Okay, so let's pull up a graphing calculator. Okay, so I'm going to put in that formula. That formula is 10 times the square root of log x plus 1. That's the difficulty formula. We zoom way out. You can see how it changes over time. Okay, this is a pretty good formula, I think, for our difficulty. And the reason being that it's logarithmic. It has this limit to it. So it doesn't just keep growing bigger and bigger and bigger as your input of bytes gets bigger and bigger and bigger. If I put in 1 byte and the difficulty is 1, and I put in 1,000,000 bytes and the difficulty is 1,000,000, well, that's going to be a really difficult thing to hash, and especially considering the maximum difficulty is 512. So we need something that continues to increase as the files get larger, but not that it stops at a certain point, but it never really goes above a certain point. It has a limit to it. So that's what this logarithmic function has for us. And it has this limit. Also, it has this really interesting starting point. It starts just at 1. So anything smaller than 1 is an imaginary number in this formula. So if I put in like 0.5, there just isn't an output. It doesn't exist. And same thing with 0. So on this difficulty formula, there is no difficulty for 0 bytes. But the difficulty for 1 byte is exactly 1, which makes that a really nice base unit for this whole thing. And then we have this exponential growth that makes it so that in order to hash, say, 10 bytes, it's going to take a very short amount of time. But in order to hash a gigabyte, you're going to need to spend a great deal more time. So that is the formula, and it needs some tweaking to it. It needs some tweaks because it seems that I feel like this curve, rather than being like this, needs to be more like this. It needs a more gradual increase here, because I mean, all of the massive increase happens over the span of 5 bytes, and that's that's a bit too quick. So the formula needs some work, but I'm having some difficulty actually getting that. So I can change the height of it. So if I do times 15, you can see it gets taller. 150, it gets way taller. And then I can put some parameters in here. Yeah, the +1 is where it ends up there. So I need to find out how this function works exactly. If you are more of a math person than I am, I would love to hear it. But that is our basic formula here. And what we get out of this is something kind of akin to mining a blockchain. So essentially, we can decide how difficult we want it to be to add certain things to the network based on their bytes. That system also provides a way for, oh, it's gone now, isn't it? But a way for, let's go ahead and go back. So look at this on the alternative. So we get our ID here. This is that hash that is generated from the file. And actually, this probably would not be stored in the final version because the ID comes from hashing the block itself. And if I hash this document and I get a certain hash, and then I insert that hash into the document, well, now it will be different when I hash it again. So this probably won't even be there. We get a reference section so that each object can reference a different object. So if you think about this in a chat network, for instance, if I am responding to you, then my block is going to reference your block, and that's sort of your previous block that you would have in a blockchain. And then we have our data section, and this is going to be, again, whatever the client defines. So we can put anything in here. And so you and I could be sending movies back and forth. We could be sending texts back and forth, whatever we want. And the speed at which we are able to send that across the network is determined by the total size of this block, because we have to generate the hash for it in order to actually identify it and send that to someone. So since our hash has a certain difficulty to it, then we can ensure that certain speed limits essentially are imposed. So someone sending movies would have to hash that entire movie file, and someone sending a text would only have to hash 255 characters. So that is the basic thinking. And what we need to do next is sort of merge that hashing and this together, but we need to really decide on the formatting of this. So right there you saw I just made an edit to take out that that ID. And so right now I have any references. So let's take a look at what we probably need to actually store in this. I'm going to open this up side by side with this one. This is my original. Close that. Okay. So first of all are the quotes. I don't think we should use quotes. So the question is, do we make this? Oh, one moment. Proto850. Thanks for the stream and videos. They are very educational and well done. Keep up the good work, and soon the channel will grow. Thank you, Proto. I appreciate that. I look at my camera when I say that so that you can know that I'm being genuine, but it's currently turned off, so you're just going to have to take my word for it. Thank you. Anyway, so first thing we got to talk about are these quotes. If I am parsing out this in C, these quotes are going to be a pain. So I think I'm going to remove. And this sort of puts the nail in the coffin that nothing we put in here is going to be JSON compliant. So you will not be able to load this as a regular JSON object, and I don't think we care. I'm open to debating that though. So actually, let's go ahead and create a poll. I'm going to ask you guys, I'll put it in the description of this video of should our putting this in the chat for you. There you go. And I'm also going to throw it on Discord. Do I have Discord up? I don't think I do. Throw it in there for them. And I'm going to okay. So yeah, let me know. Do you think we should remain JSON compliant and keep the quotes here? And we can also put quotes between these hexadecimal numbers because JSON does not recognize hexadecimal numbers. And then we could, like in this data section, we could put quotes as default so that we can just say everything in there is a string by default. To me, that seems like kind of a mess, but I'm open to your input there. So for now, I'm just going to say we're not going to use quotes, and I have given you the methodology by which you would stop me. So what we're going to do. No quotes. Okay. And what we'll probably want is this I. So the I is basically everything that's identifying who made it, okay? And I don't exactly know what needs to go in there just yet, but we know we're going to have it. So they're going to identify themselves in some way. And well, we can put this in there at the very least, this ID, because it's almost certainly going to be some sort of hash value that is identifying them. But we may have other things in there as well. So here's an option. So let's say I ask them, I'm going to open Python, and I need to sneeze. Mute the mic, I don't know how. Excuse me. Okay. I tried to make a mad dash for OBS to mute the mic there, but I failed all of you. Anyway. All right. So let's, how would I do that? Let's find a function. Say basically giving a login, but key is going to be this last one. Second pass. Second pass. And then we need create the hash based on these. So h.update. And we're going to plus password plus do I need to add all that together? Then I don't know. Whoops. This is gonna be a mess. Okay. What I'm trying to do here basically is say that we can create a login protocol basically by taking in 3 inputs. So let's say they put in the username Eric, password was password, and the second password is second password. We could hash all 3 of those together. So and then we're going to say update, and we're going to pass it this string encode so that would be my ID. So if my username was Eric, I had these 2 passwords, password and second password, that would be my identifier. And that would go in this I section here. That would be my ID. And the reason we want to do it like this, or we might, oh, we got another question from Rogue. So you're just planning on just dumping the binary data into these files. Why not encode it into hexadecimal or base 64? Great question. Let's come back to that in just a second. Let me just finish what I'm saying here. So this is my ID. And the reason we want to do it like this is that if I use the username Eric and you use the username Eric and I use the password, you use the password, we would have the same ID and we would be, it would seem like we are the same person, and that would cause problems. So if you give them 2 passwords, you make it much more unlikely that they will, you make it much more unlikely that they're going to have a duplicate of something. But it's still not a perfect solution. We might want to have like a list of users somewhere so that nobody has the same ID, because sometimes you can get, what do they call those? Conflicts? I don't remember. Anyway, we can use this to generate IDs, which we will store in each of these objects as who created it. So we know that the object contains a few things. Object contains who created it. And then here is its reference, previous block. So who it references, and what it contains. Save that for now. Okay, let's go look at Rogue's comment. So are you planning on just dumping the binary data into these files? Why not encode it in hexadecimal or base 64? So we could do that. It's the encoding thing. I'm not sure. Everyone asks about encoding and collisions. Thank you, Proto. Thank you. Everyone asks about encodings, and I was receiving a number of downvotes in in these discussions. Look at that. That's shame on my family. Anyway, yeah. Is that the same guy? Proto850? No. Anyway, I don't see why you guys are asking about encoding in this way. So we don't really need to think about encoding because it is just raw binary already. Okay, so that was basically what I was trying to demonstrate with this. This is all just raw binary. And we have some sections here that are kind of more clearly raw binary. And here, there's actually a bunch of null characters and a bunch of other escape characters that are not being displayed by text to do with these bytes, but it doesn't know what to do with these bytes. So there's like this weird effect that happens. Watch, if I move my cursor, oh, it's not doing it here. In a previous one, it would kind of like jump to the beginning, end, and middle of a line. It was strange. Anyway, this is already encoded in binary, so I'm not quite sure what you mean dumping the binary data into these files. If you mean this part, yes, we are just going to dump it in there. And it's going to look like complete nonsense, but our headers are what we are concerned with on the network. So at the level of the network itself, we care more about the wants them. Okay, whoever wants them and whoever's asking for them, it's their responsibility to display them and make them usable in some way. So let's say you could set up your block here. We could set up this so that this content was actually HTML. And we could have this HTML sent on our network. And so one node would ask for it by its ID, and it would scan the network. We would find this file. Then you on the other end would know that you are looking for an HTML file. So when you pull out this content, you're going to display it as HTML, and that's your job. So we are just going to save whatever is put here. Whatever is loaded in, that's what gets saved. And the rest of it is, so Rogue, if you are asking if I'm going to just dump this binary data here, yes, I am just going to dump the binary data into the JSON. But because we know where it begins, because we know its total size, we can pull it back out. Excuse me. Starting to feel the effects of talking for, how long has it been? Hour and a half now. Anyway, if you are, however, asking if I'm just going to dump all of this, I don't know what else I would do, because this is already just binary data. Each character is 1 byte, and it's just some byte. So yes, this will just be dumped all as binary data. It already is binary data. So I'm not quite sure what you're asking there. Maybe you could clarify a little bit. Let's see. How are we on battery? 39. We got to wait a little longer. Okay. So our object is going to contain who created it, who references it, and what it contains. And is there anything else that it needs to contain? I don't think so. Not right now. But what I want to show you is basically the algorithm by which we would parse this. So let's imagine we are creating something that is it's going to take a string and parse it. So This returns a character. Or actually, this is going to return a. Well, we'll need a struct JSON. And this is essentially just going to include a binary search tree. Let's just use. Well, actually, we just need a dictionary. Okay, so in my library, I am going to kind of assume that you have some background knowledge with what I've been up to here, but I have a dictionary object, and I can just use this dictionary object for this little thing. I'm just demonstrating it anyway. I'm not actually implementing it right now. So this is going to return a struct dictionary, and this is going to be pointer. Oh, it's called string. And okay, we have our string, and what we can do given this information. Oh, we got some more comments. D none ASCII that you have here includes carriage return line feed characters and field boundary elements. I think what they are driving at is that your protocol was binary, then you could dump the extra characters. I see. So you're saying it's more efficient if we get rid of those additional characters. I suppose it might be. Maybe you could tell me. I'm not quite sure how that would work. Would we have to go through that file and remove all those characters manually if they were there originally? Also, are you talking about like when I take my image file and like save space and transmission? Yeah, that makes sense. So are you talking about like my image file? So like when I have this, oh, I already have it open. Are you saying that there are carriage return line feeds in like this and we can remove them? Also, would I have to go through and search this one character at a time for a carriage return line feed and anything we want? You have to specify the protocol. I'm not quite sure what that means. Yeah, I think I'm comfortable just leaving exactly what they put in there. I mean, why edit it, you know? If you're sending me carriage return line feeds, why wouldn't I just store carriage return line feeds? You asked me to store that. It's almost like what you're asking is for me to use some kind of compression on it. So not quite sure about that. But let's come back to parsing this string. So essentially the way it works is that we're going to be separating the string based on predictable patterns. So the first predictable pattern is that we don't need the first character and we don't need the last character. They're just there for formatting. And we have decided that there is pretty much no formatting in structure. So if we look at the actual example, remember this is a pretty one. So this is the actual one. So there's not much formatting in this at all. But we do have some formatting like this to indicate the beginning of a dictionary or the beginning of an array. And so we are going to put it at the very beginning and the very end just to sort of wrap it up and be consistent. Hold on. Lol, let me get a keyboard. Even if. All right, D none, get a keyboard. Do what you're going to do and follow up with me because I want to hear more. Anyway. So yeah, there's already very little formatting in here, but these symbols actually represent something significant, what kind of data structure we're going to store the next section in. And the very first one is a dictionary, so we're going to leave those in there. But essentially what it means in our program is that we can ignore those first and last characters. So we look at this again. Now, the next thing we're going to do is sort of split it. So we kind of want to split it on commas. So here, okay. So what'll happen, there we go. Oh, that's better. Got a keyboard on the phone. Sorry, I will listen along. Okay, welcome. Glad you got a keyboard. Anyway, so yeah, we're basically going to split it on commas. And what we're going to do is extract that. Let's just go ahead and extract that. Then we are going to extract this. Then we extract this. And then we have that last character. So let's go ahead and just do that part. We have string.h in here. No, we're going to need it. Okay, now just an odd thing that kind of happens here is that when you pass a pointer to a character array into a function, that it becomes a string literal. And you can't alter a string literal. And the string token function is destructive. So I am going to need to make a copy of this locally. Let's see, D-none, thanks. I don't mean to be disruptive. That's okay, even though it just interrupted me. It's not your fault. I chose to look over and read it out loud without scanning it first, so I did not mean to just call you out like that. My apologies. Anyway, so what was I just saying? Oh yeah, we need a local copy of it. So let's go ahead and create a character pointer. Well, let's just create a character array called local string length. Actually, we can get rid of this. We just do this. That's easier. Okay. And then we are going to, for int I equals 0, I is going to be less than string length of string plus and then we'll say local string I equals string I. And that should copy it over. Okay, so that copies over our string literal into a local string, which we can then edit, and that is going to make it available for string token. So we're going to now split that entire string on commas. So we are going to create character. Well, first, we're going to split it on commas, and the problem that we are facing, what am I even looking for? This one. Okay. Let's do this one. Okay, so we split it on commas, right? That's going to give us this whole thing. And it's going to give us this whole thing. So it gives us the key value pair as a whole string, right? And we want to actually turn these into single individual key and value data types separately. Now, in order to do that, we need to split the string twice. We first get those two. And we can't really do that. Since string token is destructive, we aren't going to be able to do those one after the other. We have to do it in 2 steps. So first we have to do all of these. We have to do all of the key value pairs as a whole, and then we have to do all at a time. We'll see what I mean here in a moment. So we're going to create a struct linked list. Well, actually, let's make it a queue. That way it just kind of provides a slightly easier interface for pulling out items. So we're going to call it KV pairs. And it's going to be queue constructor. And so we can say
character pointer kv equals string token. We're going to do this on local string, and the separator is going to be the comma. And say kv pairs. Oh, sorry. kv pairs dot push address of kv pairs kv, and okay, so now we are going to push that key value pair into this queue, and then while, well, then we're going to want to update it. So let's do it like this. I find myself using do while statements recently, and I don't usually do that. And the fact that I've used it twice in the past 2 days is sort of making me wonder. Let's see. Valtteri Koskivori. Sorry for the original pronunciation. Nice to meet you. I'm doing exactly this for my renderer to add support for network rendering. That's interesting. Just to distribute rendering across multiple machines. So is it like the workflow? You're kind of working in a clustered environment, or essentially a supercomputer where you have multiple processors that you're trying to distribute things, or like literally multiple machines, not necessarily even in the same place, are performing calculations at the same time? Anyway, let me know. So we're going to insert each of these key value pairs as a whole into this queue. And we're going to do that in a loop. So while, okay. Okay. That's good. Okay. Yes, clustering, single master node, multiple workers. Yeah. So one thing I'm thinking for my network here is that it's not going to have a single master node, but every node will be able to serve whatever it likes and can do whatever it likes. And my node in particular is going to be offering a lot of services to the other nodes that they would need. So like, I'm not envisioning everybody storing all of the data that exists on the network in its entirety. That would be ridiculous. So most people are just going to store headers and some of the files that they have accessed recently. Maybe it'll keep a list of like 15. And I will keep a tab of all of them. I will keep everything. That way someone somewhere has a copy of everything. So yeah, that's what I'm thinking. It's not really a master node, but it is I'm going to be running a node that provides particular infrastructure services to the network. Anyway, access point for one thing. Anyway, okay, so we push that key value pair into the queue. So once we have done that, we can now say kv equals string token, and then we're going to pass it null because it saves what was left of this. So it has the rest already saved. And we're going to, again, split it on comma. We're just going to keep doing that while it returns something and continue pushing it into kv pairs. Let's see. Yeah, in my case, all the state and synced before all the state is, oh, sorry, there's an is there. Yeah, in my case, all the state is synced before rendering. Then the master node just requests portion of the image to be rendered from the workers. That's really interesting. And so does the master know what needs to be rendered, and then it just decides what the... So, very nice to see someone else using Xcode for C Pro. Yeah, Xcode. It's great. I really like it, man. I don't know why it's not so popular. But anyway, so I guess my question is, do the master node seems to know what the slave nodes need to provide it with, but do the slave nodes have the big picture view of of like what their contribution is building. That's yeah. So yeah, that's my question. Anyway, so we've got our KV pairs. We've pushed each one individually into this queue, and now we can take them out one at a time and operate on them once again. So here we're going to need our dictionary. So struct dictionary constructor, and we need a compare function here. And fortunately, I have compare string keys, something I made as part of the library. So that creates our dictionary to store our final result. And now we need to loop over the queue and basically pull out each key value pair as a whole and split them once again on the colon. Ooh, a lot of stuff going on in the chat. Oh, the master node is also rendering. Okay. Worker nodes don't know the whole thing, just the portions they rendered. Image is just split into tiles, basically. Interesting. Well, yeah, I guess that is my question. Is so the node just receives, hey, you're supposed to render these 2050 tiles, and so the node renders them, but it doesn't really know that there are more tiles out there. It doesn't know anything. That's interesting. I wonder if there would be a way to do it as a swarm where everyone just like picks a random number, and that random number is correspondent to a certain tile, and then they just will like communicate with each other, like the 5 closest, at like which one would should we move to next. Anyway, none. Plain text is not binary data. It is all encoded as binary, of course, but the idea is not. Oh, but the idea is that your number. I think there's more to that. Anyway, let's finish off here. Okay, so we created our dictionary, and now we need to loop over the queue. So actually, what we're going to do is say character pointer pair equals kv pairs dot peak, address of kv pairs, and peak is going to return the data stored at the front of the list, but it's not going to actually remove it. So I need to call pop, but if I call pop, then this becomes null. So I'm going to have to do that later. And so we can say while pair, I'm going to what? What am I going to do? So first I'm going to create a character pointer called key. That's going to be equal to string token of pair on the colon. And then we're going to have a character pointer value equals string token. Again, we're going to pass null. And here we can pass 0 because we just want the rest of it. Okay, so that extracts our key value pair. So now let's say eson.insert, and we're going to insert the address of eson, key, string length of key, value, string length of value. Okay, wow, lots going on here. Okay. 8 characters, however, as binary, it's just 32 bits, not half saving in this case. That goes for all text stuff. I see what you're saying. So I guess my question is, so I think your math is a bit wrong, actually, D none. Okay. So 1238990FA, it's a hexadecimal number, would take 8 characters. Okay. However, As binary, it's just 32 bits. Okay, well, how many bits are in 8 characters? Because every character is 1 byte. Every byte is 1 bit. So, code is on GitHub. I'll definitely check it out. But yeah, I think your math's a bit off there. Oh, I'm doing 8 times 4. Maybe my math's a bit off. Yeah, I think that would be 64 bits. So you're saying that you're encoding this, by encoding it in this hexadecimal 123890FA, you are reducing the amount of bits that it requires by a factor of 50%. I'm not quite sure how that works, so yeah, I think you're gonna need to talk more about that, because I'm really curious how that actually works. So send me a message on Discord. I'd like to talk to you more about that. Anyway, so we've created a queue out of our key value pairs as an entire string, and we had to separate all of those one at a time. Then we create our dictionary, and now we go through those key value pairs, we split the key and value, and we insert it into the dictionary. But we should do one thing before we do this, and that is to check with the key and value and see if their first character is one of the characters for our special types. That is the list or dictionary. So if value 0 equals that, or value 0 equals that, and we're just going to do printf special case. And yeah, eson.insert. Now, we have a bit of a problem here. So I don't think string token is going to be up to the task of copying in the data from a file. So while we are parsing this, we are probably going to need to see the size of the file and grab it. If you look at JSON, this is Rogue. If you look at JSON, basically every character except for white space means something to the parser. A curly brace would never get discarded. I think I'm talking about, I suppose the difference is that in JSON, sometimes their documents would start off as a array or a list rather than as a dictionary. So yeah, they would not discard the first or last character. But insofar as we are not using arrays here, we can. Unless that's not what you're talking about. Thank you for joining the Discord. I appreciate that. And you also have to look at the escape sequence that modems used to go between data and metadata mode. I'm going to bail and check back later. Love the idea of peer-to-peer. Great. I'll talk to you later, D-Nun. Thank you for joining. Okay. So yeah, we have a bit of a problem here because our value, we know, might be actually from this file. It might be this crazy stuff here. So we actually will need some way of identifying that beforehand so that we can pull all that out. So let me think. Well, it would have been inserted. It would have been inserted into the dictionary. So we could, in theory, if we mandate that, see that hash, that could be binary. Yeah, it could. Anyway, if we mandate that every time you're sending raw binary data, you have to include the size of that data, we could be on the lookout for parameters that say size. And once we see, okay, it's telling us a size, the next key value is going to be some crazy stuff, and we're just going to want to do this size. So we would have to have some sort of escape for that as well. And well, is there any other way that we could do it? We can't string token. I'm getting all turned around here. We can't use string token because this \0 exists throughout that file. So I suppose what we could do, the only option other than watching out for them to basically say the size of the data. Sorry, yeah, if we don't stipulate that they must tell us the size of the data. Extended JSON, ESON stands for embedded JSON, but I like extended better, even though it's kind of more limited. It sounds like it has extra features, which is fun. But I was thinking embedded because we're embedding files within it. Anyway, so we could check here. So like if string compare key, and we're gonna also, what would it be? Size, or if it's data, we need to do something special here. But another option is actually back to this. Or if we have the header size. So if we mandate that the header size must be up top, that'll tell us where in the file this begins. And we could also mandate that the first part of this must be this. And so we know that their content is a certain length. We could also just stop there and extract all of that until everything except the very last character is, we could just extract all of that as a string. That seems unlikely to be effective. And it depends how we are trying to use this, because really we are just trying to create and hash the files. Okay. All right. Give me one second here. I need to grab some water. Okay. Welcome back. I think we're about good for the face cam to come back for a little while. We're at 61%. Great. Be back with the face cam soon. I'm going to do a little more work here, and the chat's going pretty well. I'll do a little Q&A with you guys. and then we'll wrap it up. So we can split this basically here. And we know that everything from here to here is whatever the client sends. So we don't really need to worry about that. And we probably do need to send the header size. And then whoever is worrying about this, that's the client's problem to deal with. So they are going to have to parse out these different things. And maybe this is actual JSON. The only question is there a circumstance when we would want to send multiple things at once? So what if I want to send multiple binary files at once? So like if we have content and content. Well, again, that's the client's problem. So they are going to have to deal with however that is structured. And we want to keep in mind that people might want to do that. So we want to keep this JSON thing in such a way that it can be used in any way. So we'll keep it in mind. But for now, we are going to keep it like this. And I really want to follow up with Rogue, I believe it is, about, no, it's D none about about binaries. Anyway. Yeah, if we just assume that this starts here, then we can wait. So we can just check. So okay. What we need to do is actually extract the... See, what's interesting here is that we need to extract the... we need to extract the data from a key in the middle of inserting all of those keys and datas into the actual dictionary. So we need to grab it beforehand. It would be easier if we could just like stop copying this string once we know the size of it, you know? We know it's the first. So what if we do this? This is going to be a really sloppy way to do it, but I'm going to do it anyway. Yeah. This is a really sloppy way to do it, but okay. So what we're going to do is, okay, so character, pointer, key, equals, call it. Let's just call it SDF because we're not going to keep it long. This is definitely not sticking around. Rogue, if you're not going to use that text delimiter to determine the size of the payload, then what's protecting you against a buffer underflow? What's to stop me from sending a size of 10,000 with a 1 byte payload? The hashing algorithm. So if we come back here, here is your difficulty in hashing something. So if you put in a size of 10,000 to this, so it'll be 10 times square root of log 10,000 plus 1. It's a difficulty of 21. And that would take you about, maybe, depending on on this particular difficulty function, if you're running it on a MacBook Pro like I am, difficulty of 21 may take 5-10 minutes to hash, depends. And yeah, you could create that. It's fine. You create that 10,000 byte document with a 1 byte payload, then that's fine. You're going to have to hash it. The limiting factor in here is in creating the document in the first place. So if you can put in the time to create that document, then you can put it on the network. I'm not sure why, frankly, I'm not sure why I would care that that you have this very large document with 1 byte of actual data in it. That's not a very interesting document to me. I don't see what the problem is in me getting that. So maybe, I mean, it could just be that this is just some area of hacking technologies that I'm not familiar with, but that doesn't really sound like a problem. me. So I don't know. Anyway, so I'm just going to call this thing ASDF for now. I'm going to need to come up with a better name for that, but we're going to use string token. We're going to use it on local string, and we're going to separate it on very first colon. Okay? It's going to be stupid. And then character pointer called num is going to equal string token null, and we're going to separate it on comma. So that's where it's going to get that first one. And we know that header fields, or the length of the header length, that field, header length, is the first one. So we can now do this again. So now we recopy local string, and we've extracted num, and now we basically just put it back because string token is destructive. Okay. Problem is that your parser will then try to read 10,000 bytes off a document that only contains a few bytes. So the program is just going to run off the end of that buffer, start reading the memory that belongs to other things. I wrote my own more modern feeling wrappers for most of the string pointer family functions. Oh, that was a different person. Okay, that's that makes more sense. Anyway. Okay. My parser. Are you saying that like the thing I'm writing right here is going to run right off the end of the document? I don't see it would. Why it would? Because we know the document size to begin with. So we know how to calculate the size of the entire document, so that wouldn't really be a problem. And it depends. If you're talking about my parser, then from what I can see, I think at least that it wouldn't be a problem because we know that the size of the entire document, so we kind of know where to stop. If you're saying that the client's parser at the client, whoever's accessing that file and trying to display whatever is in there, they might run into that problem. Indeed, they might. And so they would want to have a parser that will handle that. But again, that's the client's issue. That's not our issue. Think about it like if you sent an HTTP request that had this buffer overflow thing, or if you sent a file over HTTP with a buffer overflow or underflow, excuse me. Not really HTTP's problem. HTTP is the mechanism by which our computers are communicating. What we are communicating about need not make sense. So, anyway, okay. So yeah, we're just gonna pull out that part of the local string, and then we're gonna put it back, and then we are going to create our int. Well, let's call it long. F size equals F size, and we can do s print f, and we're going to put this in. What is it? Wait a minute. No, that's not the one I want. How do I get the number out of the string? Okay. Okay, so you're using a text delimiter to determine the size. Why even send the size? Okay, well, that is for, do I have that example here? Yeah, okay. That's the header size. Okay, so I can, from outside the document, without opening it and without reading it, I can tell you the number of bytes of this file. Okay, it's just something that the computer is able to do, is know the size of the file. So I would know that the size that you sent me is 10,000. And then I open it and I read it and I say that this first key value pair is the header size. Okay, that is the size from here to here. Okay, that is how many bytes are between here and here. So you know, as the client, that what you need to deal with, your responsibility is to parse everything after that until the last character. And whether all of that is HTML or JSON or more ESON or some binary data. Doesn't matter. It's your responsibility to parse that. So yes, I'm using this text delimiter to get the size, but it's the size of the header fields, the size of this. And then this is just the client's responsibility. And I'm not even sure I need the header size, because if we think about this, again, I can be strict in this section. So in this external section, I could also say this, okay? So there's nothing else in here that's going to say data colon. And since I am stipulating what keys go up here, like I can specify that these keys go here and only these keys go here, and these keys have to go here. I can be really strict about that on the network. And since I know what goes into the parameters for those keys, then I can know that this is not going to show up. So I could just use a text delimiter up until here, and then leave the rest of it to be the client's responsibility, or at least that part of it. Or I could put in the size and make it a little more dynamic. So there are some decisions that need to be made so far, and I don't, honestly, I don't feel comfortable making those decisions right now. So I want to build more of the network out and start trying to play with things before I start making a final decision about what these are going to look like. And that's kind of making it difficult to progress, because I know what I want to be doing, but there are some decisions that kind of need to be made before we can do it. So it's been a bit of a challenge. Anyway, where were we? So let's, okay. So, oh boy. Yeah. All right. So here's what we're going to do. We're going to say, okay, we're going to create our local string. Okay, so we've created our local string, and what I'm doing now is basing it off of this. And I want to essentially extract down to, and so what I'm doing is copying everything, all of this, over as a string, and then I'm going to use string token on data colon. And it should give me everything too. Okay, so that gives me the headers. And we will parse the headers in their key value pairs. Doing this local string. Headers. And we do the same thing here. Okay. And the last thing we need to do is, okay, we're going to create a character pointer called K, and we're going to call this data. Create a void pointer data, and I want to copy over what's left in local string. Well, I suppose local string itself could work. So yeah, let's use that. Okay. So local string was destroyed when we did the where is it? When we extracted headers, it extracted everything up to data and actually cut it. And it also cut the data itself out. So what we are left with is just the remainder of the file, which is going to be all of this. So we essentially want to extract out everything minus, well, in this case, 2, depending on how we... No. Rid of that comma. Yeah, so we want to extract everything except the last character. So, insert. Oops. Okay, so we need the address of JSON. We want K, then string length of K, and then we want local string length, local string. Is that what we want? So I want to remove that last character, remember, from the format here. I want to remove this last -1. That should subtract 1 byte, which should just give us minus the last byte, unless they're considering the last byte to be the null terminal character, but we'll see. Okay. And turn JSON. You know what? Let's just call this. It's gonna be a bit awkward with copying it since I was imagining this being a parameter and it no longer is. What's going on here? Oh. Okay. So now I've inserted the data into our dictionary. And what I want to do is extract it and write it to an actual file. Okay. So what I want to do is create a file pointer called output. I want to open and we're going to okay, so we'll have a void pointer called data. Well, we'll call it D. And we're going to set it equal to eson.search. Now we have to pass it the address of eson, pass it the search key that we're looking for, and create a character pointer called query. We're going to set that equal to data. And we're going to search for query. Okay. And then okay, so I don't know. Yeah, so here's an issue. Well, here's what I'm going to do. I'm going to put D there, and I'm going to put output there to write it, but I don't know the size of it. And I can't use any functions since it's in a void pointer at the moment. I can't use any functions to calculate that size. So where am I going to get the size of that? I know it's up here. Okay, let's hack it for now. I'm gonna cast this to a character pointer. I don't think that'll work. That's not gonna work. String length. There's gonna be null terminal characters in the middle of it. It's a binary file. So what am I going to do? Let's see. Let's think. What am I going to do? How am I going to get the size of it? It would be saved in the data. See, I am maybe throw a size t arg into that search API. Oh, I see what you're saying. So that in this search, I would pass it a pointer to a size t variable, and then when it gets there, it would. It knows the size in there. I don't know that it does. C. No, it doesn't. I don't think it does. See, it has the key and the value both as void pointers, and I don't save the actual key size or the value size. Though we could edit this dictionary so that it saves that size, but that kind of makes it dependent on the library and in such a way that could be confusing. So one of the things that's important here is having things match the data. So I want my data types to look like my blocks here. Okay. Yeah, so yeah. I could store the size of it in this linked list or in this dictionary. It would not match what I have here because that's not quite how they do it, but it might actually be necessary. So yeah, because then I can put. But that being said, that's not really how these things are designed because this ESON, this dictionary object, is designed so that you don't have to think about the nodes that objects are stored in. You just have to think about the data that's stored in them. And yeah, so this search function only returns the data that's stored in them. It does not return the node that stores them. So it's not quite meant for that. So we need something different here. For now, I can cheat. Can do string length of string minus string length of header. We'll just cheat for now, and I'll have to do something elegant later. Okay. You know what? There we go. Okay. I'm not quite sure if this is going to work. It might not. And we're going to need to actually okay, we have that. And I don't know why I can't open this. Okay. I have a solution. going to check the very bottom of this. Uh-oh. Text that it doesn't like it. I'm basically just trying to recreate this so that I can easily do it, but oh boy, things are kind of falling apart. We're going to have to force quit. Okay, sorry. There we go. Okay. That's why I have a backup here. So one of my functions up top actually will add the image file to it. So one of these, write image into ESON. Run it once. And that's fine. We don't need it to work right there. So get rid of this. And now let's open up that ESON file and actually read it so that we can actually perform this on a real document and try it. Okay, so file, pointer, ESON equals fopen, and this is going to be I'm going to open this in read mode. Okay. And then long size equals get file size ESON and then character local string of size bytes. Okay, we're almost there. And then memcopy destination is local string. The source is going to be ESON. Size T is size. Okay. That should do it. Headers out. We get that. This. Uh-oh. Okay. Is that gonna work? Might. It might. Let's see. No. Didn't like trying to insert that. Okay. So usually that's because I do. Oh, we're almost there. data. Getting anything out of this? See, something is stored. Got something stored there, but it doesn't like string length of headers. String length of headers. That should be fine. Right here. What is header? Oh, okay. Well, that makes sense. Shouldn't be, but it is. Ah, okay. Okay. Again. Hmm. Oh, I didn't read the file, and of course. Well, didn't I? Is there anything in this file? No? Doesn't seem to be doing this, actually. Got some. I have a question. Can I ask? You may ask, Hiru. And rogue. Size of character string length. How's that supposed to work? Size of is evaluated at compile time. String length is a function. Yeah. Yeah. Okay. This is. Every time I do this, everybody asks me about it, and I know it's dumb, but it's for some reason if I do it in other ways, it will read beyond where I'm trying to read or not read quite enough. So I have found that this is the only way to get the precision I want. I mean, look, it's a string length of k should do it because that's just how many bytes are in it. That should do it. But for some reason, that does not give me consistently accurate results. So yeah, unfortunate. So Hiru, is it necessary to learn all C and C++ libraries? First of all, there's no need to yell. Okay. So no. No, it is not. Why would you? There's so many libraries out there that would be absolutely impossible. There are some standard ones, and most of the standard libraries you're probably just going to start using, and you'll remember them anyway. So it's really not an issue. Okay, maybe you shouldn't use VLAs. They're pretty dangerous anyway. What is a VLA? I don't know what that is. Maybe I'll figure it out in time. Anyway, we're getting a problem here. String length of headers. So local string didn't actually get anything in it. So yeah, we got that. Got that. Got that. Maybe we need to do an old-fashioned for loop. I don't know what we're yelling about. Oh, variable length array. They're pretty dangerous. Variable length array. Well, things are kind of crashing over here anyway. So at least the stream is still running. So, okay, I was worried for a minute there that everything had crashed. Anyway, let's see. Where even am I? I need to plug back in. So Facecam's going to have to go. We're only going to go for a few more minutes here anyway. So I'm going to pull out the cam. Plug in the Mac. Okay, let's keep going. Let's keep rolling. Okay. Gotta get the headers out of there. So, for int I equals 0, I is less than size plus local string I going to equal JSON file. Can we even do that? I don't even know if that works. Yeah. Almost certainly not gonna. Yeah, okay. Hmm. Maybe if I do this. Okay, so F right. And it's going to go to from ESON file. Size T is size. This is where it's going to. So I know it's supposed to be the file goes here, but I wonder if that will work. Probably not. Well, okay. Okay. We're gonna have to use malloc. This is getting kind of sloppy, so it gives me something to play with for the rest of the week, but just need to remember to free it, of course. Yep, that's right. Void pointer E equals malloc size. Okay. And then we are going to say F E. We're going to put it in E file pointer restrict comes from ESON file. Okay, I think that's done it. You do a search of VLAs and you'll find reasons why they're discouraged. The Linux kernel has banned them for a good reason. Okay, I will look into that. Thank you. All right, let's see here. What's the last thing we got to do? Okay, we'll call this. I had a feeling this wasn't going to work. Oh, maybe it did. Let's do some more work on this later. Yep, doesn't like that. All right. Pair. Okay. It should have another section to that. The pair is not getting pulled out correctly. Well, got the first part of it. It's just the next part. It should have extracted all of this. Oh, actually, it should have extracted. Should have extracted this as its value, right? But it didn't. So let's come over here. break there. Let's see what happens. Okay, so first it is I. That doesn't make any sense because we split headers on a comma. Oh, wait a minute. Oh, okay. Okay. What is the name of this IDE? This is Xcode. It's for Mac OS. And I have to head out now, though later. I'll see you later, Valtteri. I think I'm pronouncing that correctly. I'm glad you'll be joining us on Discord. Anyway, because I appreciated your input. Anyway, so our KV is I, and string token can only split on a single character. So, okay. I'm having some trouble here, and I don't think I'm going to be able to get this part of it today, but that's okay. We're going to come back to this. I think that today I've done a decent enough job at explaining what all this actually is. We are trying to build a system of communication for these nodes on a network by which we can wrap metadata and data together. And our data can be anything. It can be binary executables. It could be absolutely whatever we want, but we wrap it in this kind of header so that we can find it, identify it, and transfer it on the network. And as part of this, we use some sort of blockchain-like things where we are hashing our files in order to identify them. And it will set a certain difficulty on the hash for a certain file and things like that. So that is basically what we are working on here. Today we are trying to nail down more about our protocol. We've gotten quite a lot defined here, but there's a lot more that we need to define yet. And most of that is going to come as we start actually working on it and start using it. We'll start seeing that a little bit more. So thank you for joining me today. I am going to plug in my to survive on a little. There we go. So thank you for joining me today. I'm very glad you were here. If you liked this, feel free to subscribe to the channel and leave a like on the video. I do live streams on Saturdays at 9 a.m., usually on C content. We did a lot less programming this week than I usually do. Usually it focuses almost entirely on C. And I also upload fairly regularly during the week about different concepts and teaching more about how to program in C. So I hope you enjoyed this. Thank you for joining me, and I will see you next time. Toodaloo. And I have to awkwardly now end the stream. See you guys.